So if 10 different people tell you they saw someone commit a crime, your common sense probably tells you that's a rock-solid case.
Right. I mean, it just feels intuitive.
Exactly. We operate on this, fundamental everyday assumption, this idea that if you gather enough weak clues and they're all generally pointing in the exact same direction, they must eventually combine to form an undeniable proof.
Yeah, you assume that where there's smoke, there's fire.
Right. But what if the laws of pure mathematics prove that those 10 witnesses might actually make it more likely you've got the wrong person?
Which is a crazy thought.
It is. What if that entire web of guilt, built on dozens of tiny pointing arrows, is literally just a statistical illusion?
It's a profoundly unsettling thought, especially when you realize that people's lives, their liberty, their entire futures are routinely decided based on that exact illusion.
Yeah, every single day in courtrooms all over the world.
Right. And, the human brain is a wonderful pattern matching machine, but it is just notoriously terrible at intuitive probability.
Oh, absolutely terrible.
We see a bunch of small arrows pointing to the right, and we just assume, well, the destination must be to the right. And we do this without ever stopping to actually calculate the mathematical weight of those individual arrows.
So today, for you listening, we are looking at a truly paradigm-shifting paper. It's titled Evidence, Circumstantial Evidence, and the Reasonable Doubt.
Yeah, and the author here is key.
Exactly. This is by Giancarlo Monteverdi. He's a former state police chief commissioner and a Europol intelligence analyst.
Right, so this isn't just some abstract math from someone locked away in an ivory tower,
No, not at all. This comes from someone who has spent a massive career in the actual trenches of criminal analysis.
Dealing with real evidence.
Real evidence, real suspects, and very real consequences.
Yeah.
So the goal of this deep dive today is to take Monteverdi's work, which he actually describes as a mathematical scalpel, and we're going to apply it to the underlying logic of our entire legal system.
And to really understand what Monteverdi is dissecting here, we have to start with this foundational axiom. It's a concept that has literally guided courts for centuries.
Right, the Latin phrase.
Yeah, in Latin it's known as plures indicia conjuncti probent.
And that translates to something like multiple clues joined together constitute a proof, right?
Roughly, yes.
Yeah.
It's the legal justification for basically accumulating circumstantial evidence until it supposedly crosses this magical threshold into absolute certainty.
It's the classic TV lawyer move. The prosecutor stands up, they hold up a slightly scuffed shoe, maybe a strange 3-second phone call, a dropped receipt.
Right, and they tell the jury that while these are weak on their own, together, they form this unbreakable bond.
An ironclad web.
Exactly. But when we actually apply the laws of probability to this specifically Bayes' theorem and the concept of weighted averages, we're going to see why this ancient axiom is, in many critical situations, just a complete logical fallacy.
Okay, so before we bring Thomas Bayes and all his math into the courtroom, I think we need to establish the baseline of what we're even measuring here.
For the good idea.
Like, why does the legal system draw such a rigid line between what they call a proof and what is just a circumstantial clue?
Well, I mean, it really is the most critical distinction in all of jurisprudence. Monteverdi establishes this by defining a proof with a capital P in the absolute strictest sense of the word.
Okay, so what is that strict definition?
A proof is an element of information that is entirely, unequivocally reliable.
Like 100% certainty.
Mathematically, yes, it represents absolute certainty. You can think of it as the perfect witness.
The perfect witness.
Right. If this infallible entity takes the stand and says X is guilty, well, the entire nature of the case shifts instantly. It's no longer a hypothesis.
Or a really strong suspicion.
Right. It becomes an absolute fact. The defining characteristic of a proof is that it represents the fact directly.
So it doesn't require the judge or the jury to make any weird intermediate logical leaps to get there.
Exactly. The information is the fact itself.
Okay, so for everyone listening, let's ground this. If we have a security camera that captures a suspect's face in ultra-high definition, right? Like clearly committing the crime, with zero possibility of deepfake, zero tampering, that is our perfect witness.
That's the ideal, yes.
It takes the jury directly from the evidence to the conclusion, with absolutely no stops in between.
Precisely. And this leads to a really fascinating mathematical consequence that Monteverdi brings up, known as the principle of redundancy.
The principle of redundancy.
Yeah, because a proof is, by definition, absolutely reliable. It is completely self-sufficient.
Okay, walk me through that.
So let's say you have that perfect security footage you just mentioned.
Got it.
Now imagine the prosecution finds a second perfect witness, like an infallible human who stood there and saw the exact same thing with 100% accuracy.
Okay.
Does bringing in that second perfect witness make the fact more true?
I mean, logically, as a prosecutor, you'd want to present it just to overwhelm the jury, right?
Sure, for the psychological impact.
But mathematically, the answer has to be no. The fact is already established. It's already at 100%.
Exactly. Mathematically, 1 times 1 equals 1. You cannot exceed absolute certainty.
Right. There is no such thing as being more than completely guilty.
There isn't. Therefore, there is no hierarchy of proof based on quantity. Accumulating absolute truths does not increase the overall truth value of the system.
Because the ceiling has already been reached. It's like having a bucket that is already 100% full of water.
That's a great way to look at it.
If a second witness comes along and pours another full bucket in, the water just spills over. The original bucket doesn't get 200% full.
Right. The legal system, in its ideal state, would only deal in these full buckets. It would only deal in proofs.
But that's the glaring issue with this whole setup, isn't it? I mean, in reality, outside of theoretical models and pure math, who or what is ever that perfect?
Almost nothing. I mean, the perfect witness is basically a theoretical limit.
Yeah, because we are dealing with flawed humans.
In the real world of imperfect human perception, biased memories, and just chaotic circumstantial events, we are dealing almost entirely in the realm of clues.
Which, in Italian law, as the paper points out, is called the indizio, right?
Yes, the indizio. A clue or circumstantial evidence is defined as an element of information that has less than maximum reliability.
So it's inherently ambiguous, or at least partial.
Exactly. And unlike a direct proof, a clue cannot stand alone. It desperately needs logical inference to connect it to the main crime.
Okay, so if the police find a suspect's car parked, say, 3 blocks away from a crime scene, the undeniable fact is just the car was there.
Right. That is what the law calls a secondary fact.
So to get to the main fact, the fact that the suspect committed the crime, the jury has to build a bridge in their minds.
They have to infer that because the car was there, the suspect was there. And because the suspect was there, they must have pulled the trigger.
Right. It requires a bridge of logic, which is usually based on just common experience or maybe scientific probability.
And because clues carry that inherent uncertainty, they have to be graded on a mathematical scale.
Okay, how does that scale work?
Well, you can have a strong clue, like a highly reliable eyewitness who saw someone matching the suspect's description in broad daylight. We might estimate their reliability at, say, 80 or 90%.
Still not 100, but very strong.
Right. But you can also have a very weak clue, like a witness with poor eyesight who saw a fleeting shadow in the dark. Their reliability might be way down at 10 or 20%.
So the ultimate takeaway here for you listening is that the leap from a clue to a proof isn't achieved by just gathering more clues.
Not at all.
A clue theoretically only transforms into a proof if its individual reliability hits that absolute maximum mark of 100%.
Yes, exactly.
You can't just pile up a bunch of 20% reliable clues and expect them to magically fuse into a definitive proof.
They are fundamentally different categories of information.
Which really forces us to ask the big question. If clues are just fractions of certainty, 50% here, 80% there, how do we actually calculate the total weight of a case?
How do we mathematically add these fractions together?
Yeah, how does that work in reality?
This is where we bring in Thomas Bayes and Pierre-Simon Laplace. We have to look at how courts update their beliefs.
Okay, so we're bringing in the heavy hitters of probability.
Right. Thomas Bayes was an 18th century statistician, and his theorem, which was later formalized by Laplace, is the absolute cornerstone of how we calculate probability when new evidence is introduced.
So Bayes' theorem is essentially the math of updating your beliefs based on new data.
Exactly.
Which, if you think about it, perfectly mirrors what happens in a trial. The jury starts with the presumption of innocence.
That's their baseline belief, yes.
Then the prosecutor introduces the first clue, and the jury has to mentally update that belief.
Then clue number 2 comes along, and they update it again.
So how does Monteverdi apply this to the courtroom?
He applies Bayes' theorem to a sequence of independent clues to figure out the global reliability of a case.
Global reliability meaning the overall strength of the entire case against the suspect.
Exactly. Conceptually, to find that overall reliability, the formula looks at 2 competing forces.
Okay, what are they?
It takes the product of the probabilities that each clue is true, and it weighs that against the product of the probabilities that each clue is false.
So it's essentially a mathematical tug of war between the evidence pointing toward guilt and the inherent error rate of that exact same evidence.
That's a highly effective way to visualize it.
Let me make sure I'm picturing this correctly for everyone listening. If I have two clues, I am essentially multiplying the chance that clue A is true by the chance that clue B is true.
Right.
And that gives me a number representing the truth side of the rope in this tug of war.
Yes.
Then I multiply the chance that clue A is false by the chance that clue B is false. And that gives me the false side of the rope.
Correct. And Bayes' formula basically balances these two sides to give you the updated global probability of the whole case.
Okay, I'm with you.
And when you run a sequence of clues through this Bayesian formula, it reveals something completely counterintuitive about how we evaluate evidence.
This is the mind-blowing part of the paper.
It really is. Monteverdi calls it the most crucial revelation of his entire analysis. We can think of it as the greater than 50% rule.
The greater than 50% rule. Okay, lay it on us.
The math proves, unequivocally, that an additional clue only increases the overall reliability of a case if its individual reliability is strictly greater than 50%.
Wait, hold on. Let me get this straight.
Go ahead.
If I have 10 witnesses who say they saw the suspect, but it was pitch black outside, it was pouring rain, and they all have terrible eyesight, let's say their individual reliability is realistically only 20%.
Okay, a 20% reliability.
My gut immediately says 10 bad witnesses are still better than having 0 witnesses. I mean, they saw something.
That is what your intuition tells you.
So how can putting them on the stand actually hurt the case?
Because if a clue is less than 50% reliable, it means it has a higher probability of being false than being true.
Okay.
It is mathematically generating more error than truth. So when you plug a 20% reliable clue into Bayes' theorem, that false side of the tug of war we talked about gets a massive pull.
Oh, I see.
It doesn't just fail to add value, it actively subtracts value. It decreases the overall global reliability of the system.
Because you are injecting more error into the overall equation.
Exactly. Quantity does not make quality. In this specific scenario, quantity actively destroys whatever quality you might have started with.
That is wild. The idea that a piece of evidence could actually make your case mathematically weaker just by existing is completely opposite to how prosecutors present cases on television.
And in real life, unfortunately. Monteverdi brings in a very famous, tragically real example to illustrate this exact mathematical failure.
The Enzo Tortora case.
Yes, the Enzo Tortora case in Italy.
For those of you unfamiliar with Italian history, Enzo Tortora was a massively popular television host in Italy back in the 1980s. I mean, he was a household name, universally loved by the public.
He was everywhere.
And seemingly out of nowhere, he was arrested and accused of being a major figure in the Camorra, which is the Neapolitan mafia.
It was an absolute media circus, a complete frenzy.
And the prosecution's entire strategy rested on the exact fallacy we are discussing right now.
Right. They didn't have a single piece of direct proof. No smoking gun.
So what did they have?
What they had was a massive quantity of highly unreliable witnesses.
Yeah.
They brought in something like 19 different pentiti.
Pentiti being the mobsters turning state's evidence in exchange for leniency, right?
Exactly.
So these were career criminals looking for reduced sentences. Their individual reliability was incredibly low. They were highly motivated to lie, to embellish, or just to repeat rumors they had heard through the grapevine.
Right. Their individual reliability was undeniably well below 50%.
But the prosecution still used them.
They did. Because they were operating on that flawed human intuition of plurs indicia conjuncti probant. They genuinely believed that because there were 19 of them, their weak testimonies somehow accumulated into a fortress of truth.
The logic was basically, come on, how could 19 separate people all be making this up? Where there is this much smoke, there must be a massive fire.
But the Bayesian math cuts right through that smoke.
It completely destroys it.
It does. The math proves that a multitude of what the paper refers to as foolish affirmations doesn't sum up to a truth.
Because 19 lies don't make a fact.
When you add 19 clues that are all generating more error than truth, the Bayesian probability plummets.
Wow.
The global reliability of the Tortora case wasn't rising with every new mobster taking the stand. It was actually accelerating downward toward zero.
So they were mathematically proving his innocence while fully convinced they were proving his guilt. Just a total tragedy. Tortora was eventually fully acquitted, right?
He was. But only after his life, his career, and his health were completely ruined by a judicial system that just failed to understand basic probability.
To help visualize this dynamic for you listening, Monteverdi provides a really brilliant graph in the paper. He plots 3 different Bayesian curves as you increase the number of clues on the x-axis.
Yeah, it's a very helpful visual. Imagine 3 lines starting on the left side of a graph and moving to the right as we add more and more clues to a hypothetical case.
Walk us through what these curves look like. Let's start with the first one.
The first line is the green line. This represents clues that are greater than 50% reliable.
So good. Solid clues.
Right, let's say they are 75% accurate.
Yeah.
As you add more of these strong clues, the green line arches upward beautifully. It climbs higher and higher, getting closer and closer to maximum certainty at the very top of the graph.
But there is a catch with that green line, right?
There is. It approaches certainty asymptotically.
Meaning it never actually hits the ceiling.
Exactly. Gets infinitesimally close, but never actually touches absolute certainty 100%.
Wow.
Because you are still multiplying fractions of doubt.
Right. A shadow of a doubt always remains no matter how much good evidence you have. Okay, what about the other lines?
The middle line, the blue line, represents clues that are exactly 50% reliable.
Literally a pure coin toss.
Just a coin toss. As you add more of these clues, the blue line remains a perfectly flat, horizontal flat line across the middle of the graph.
It doesn't move up or down.
Nope. It's a state of permanent, unchanging uncertainty. You could add 1,000,000 50% clues, and your case doesn't get a single millimeter stronger or weaker.
It is purely mathematical static.
Pure static.
Okay, and the final line.
The red line. This represents clues that are less than 50% reliable.
Like our 20% witnesses in the rain or the 19 mobsters in the Tortora case.
Yes. As you add more of these bad clues, the red curve rapidly collapses downward, approaching 0% probability.
So the more bad evidence you introduce, the closer you get to mathematically disproving your own case.
Exactly. It means prosecutors are playing a very dangerous game when they try to pad their cases with weak witnesses just to make the jury feel like there is a mountain of evidence.
But this brings up a massive intuitive counterargument. I mean, my brain is screaming this right now.
Let's hear it.
We just established that bad clues drag down a case. But what if those bad witnesses all say the exact same thing?
Yeah.
If 10 terrible near-blind witnesses all point at the exact same person in a police lineup, surely their agreement proves they must be telling the truth. How could they all guess the same wrong guy?
That right there is the ultimate trap for human intuition. Monteverdi calls it the concordance paradox.
The concordance paradox.
Yes, and it proves that agreement does not necessarily equal truth, especially when you are dealing with unreliable sources.
Okay, let's break down how this paradox actually works.
Monteverdi sets up a theoretical model to test this specific scenario. It's called the 3-witness model.
Okay, we have 3 witnesses.
And we're going to look at independent witnesses, meaning they haven't spoken to each other, they haven't read the news, they're totally isolated in separate rooms.
Completely independent.
Right. Now, we have witness A, who is a solid, decent witness.
Right.
Let's say witness A is 66% reliable. 2/3 of the time, they identify the correct person.
Okay, witness A is our anchor. They're pretty good.
Then we have witness B and witness C. These two are weak witnesses.
How weak?
They are each only 33% reliable. So 2/3 of the time, B and C get it wrong.
Got it.
Now, a crime has been committed, and the police have 2 suspects, suspect X and suspect Y.
And who actually did it?
The true culprit in objective reality is suspect X.
Okay, so X is the bad guy. Witness A is 66% accurate. Witness B and witness C are 33% accurate.
Exactly. So we ask all 3 witnesses to independently identify the culprit. To see how this plays out mathematically, we have to look at the combinatorics of falsehood.
That sounds complicated. What does that mean?
We basically have to map out every single possible combination of what these 3 people could say.
Oh, like a branching tree of possibilities.
Exactly like a branching tree. Witness A can say X or Y. From each of those branches, witness B can say X or Y. And from each of those, witness C can say X or Y.
So you just follow every branch to the end.
Right. And when you run the combinatorics, balancing those 2/3 and 1/3 probabilities across 3 independent actors, you end up with 27 possible statistical pathways.
27 different ways this testimony could unfold in front of the jury.
Yes. Now let's look for the prosecutor's absolute dream scenario. Total concordance.
Meaning all 3 witnesses point at the exact same person.
Exactly. Out of the 27 possible combinations, how many times do you think all 3 witnesses completely agree?
Well, if B and C are wrong most of the time, I'd imagine total agreement doesn't happen very often. It must be rare.
It is. They only agree completely 6 times out of the 27 possibility.
Okay, 6 times out of 27.
But here is where the paradox just shatters our intuition. Of those 6 times where they perfectly agree, how many times do they agree on the truth, meaning they all point to suspect X?
Let me think through the probability here. For all of them to point to X, witness A has to hit their 66% chance of being right.
Correct.
But then witness B has to hit their narrow 33% chance, and witness C also has to hit their narrow 33% chance at the exact same time. It requires all three to basically beat their own odds simultaneously.
Exactly. It's a statistical needle in a haystack. The math shows that they only agree on the truth 2 times out of those 27 paths.
2 times? Wait, so if they agree on the truth 2 times, but there are 6 total times they agree, what are the other 4 times?
The other 4 times they are in total perfect agreement on a falsehood. They all point to suspect Y.
Wait. I want to make sure the implications of this are crystal clear for the listener. You are saying that if I have a room full of generally weak witnesses and they all independently point the finger at the exact same wrong suspect, mathematically, that is twice as likely to happen as them all pointing at the right suspect.
Yes. They agree on a lie 4 times, and they agree on the truth only 2 times. They are mathematically twice as likely to be perfectly concordant on a falsehood than they are on the truth.
That is insane. Why does that happen? It feels so wrong to our brains.
Because the weak witnesses, B and C, have a 66% chance of being wrong. They have a dominant, overwhelming tendency toward error.
Okay.
The probability of their massive error rates overlapping with each other and dragging witness A down into an error as well is statistically much higher than the probability of all 3 of them defying the odds and getting it right at the same time.
So the gravity of their shared unreliability just pulls the whole system toward a false consensus.
That's exactly what happened.
This completely debunks the idea that if everyone says the same thing, it must be true. I mean, we rely on that heuristic all the time.
We really do.
If 3 people tell me a restaurant is terrible, I just assume it's true. But if those 3 people have terrible taste to begin with, their agreement might actually just be a mathematical artifact of their shared unreliability.
Right. It's not a reflection of the restaurant's actual quality at all.
Wow.
And Monteverdi's analysis goes even deeper into this trap. Let's look at the times when the witnesses disagree.
Okay, let's look at the disagreements.
Remember, there are 21 times out of 27 where the testimony is split. It's not unanimous.
Right.
When they disagree, what is usually happening? The math shows that witness A, the 66% reliable one, is usually telling the truth all by themselves, standing alone against witnesses B and C, who are jointly pointing at the wrong person.
So in the courtroom, the one person actually telling the truth looks like the confused outlier.
Yes. The jury looks at witness A and says, well, B and C agree with each other, so A must be the one who is mistaken.
And that is exactly how wrongful convictions happen.
The smartest, mathematically soundest strategy for a judge or a jury is to throw out the concordant weak witnesses entirely.
Just ignore B and C completely.
Ignore them completely and keep the single strong dissenting witness. Keep A. But human psychology makes that almost impossible to do.
Because we're so desperate for consensus, it feels safe.
Exactly. Monteverdi relies on the work of Daniel Kahneman and Amos Tversky to explain this.
The psychologists.
Right. They were Nobel Prize-winning psychologists who pioneered the study of cognitive biases.
Oh, they wrote Thinking Fast and Slow, right?
Yes, exactly. And they proved over and over again how vulnerable human judgment is to these exact types of probabilistic illusions. We use what Kahneman calls System 1 thinking.
Which is the fast, instinctive, emotional processing.
Right. We see agreement, and our brains release a little hit of dopamine. We feel safe in the consensus.
We don't want to engage System 2 thinking.
No, we don't. System 2 is the slow, deliberate, mathematical calculation. We avoid it, and so we fail to realize that the consensus is built on a foundation of statistical garbage.
That explains so much about how juries operate. But let's add another layer of complexity to this.
Right.
That entire paradox relied on the witnesses being independent, right?
Yes, entirely isolated.
But what happens when they aren't independent? In high-profile cases, witnesses talk. They read the same news articles, they watch the same broadcasts. They might even literally talk in the hallway outside the courtroom.
This is a huge problem. When clues are dependent on one another, the Bayesian model actually breaks down.
You can't use Bayes anymore.
No, you cannot use Bayes' theorem if the variables influence each other. So Monteverdi sets up a brand new model to measure what happens when evidence contaminates other evidence.
Okay, what does he call this one?
This is the echo chamber.
The echo chamber. How does this dependent model work?
We start with witness A again. Witness A is highly reliable. Let's say they tell the truth 75% of the time.
A 3 out of 4 chance there. Spot on.
Right. Now we introduce witness B. But witness B's reliability is entirely dependent on witness A.
Okay, how so?
If witness A tells the truth, witness B will also tell the truth 75% of the time.
So far, that sounds reasonable. If A gets it right, B usually gets it right too.
But here is the critical failure point.
Yeah.
If witness A makes a mistake and lies or misidentifies the suspect, witness B is completely, totally influenced by that error.
Oh, no.
If A lies, B lies 100% of the time. B abandons their own perception and just parrots whatever false narrative A put out into the world.
This is incredibly relevant to modern information systems. I mean, it's exactly like retweeting a fake news article.
It really is.
If 1 million people retweet a fabricated story, you don't have 1 million independent sources verifying the facts. You don't have a mountain of evidence.
No, you just have one original error that got photocopied 1 million times.
That is the perfect analogy for what happens in a dependent evidentiary system.
So let's run the numbers on this echo chamber model. Because witness A has 4 possible outcomes, 3 true, 1 false, and witness B reacts to those specific outcomes, we can methodically map out 16 possible combinatory outcomes in this scenario.
Okay, 16 outcomes. Out of those 16, how often do they end up agreeing with each other? Because to a jury, 2 people saying the exact same thing looks like really powerful corroboration.
They agree a lot. Out of the 16 possible outcomes, they give perfectly concordant testimony 13 times.
Wow, 13 out of 16.
The system looks incredibly cohesive and reliable, but we have to look closer at those 13 instances of agreement. 9 of those times, they're agreeing on the truth.
Okay, 9 out of 13 isn't terrible. That feels like the system is mostly working.
It is mostly working when A is right. But what about the other 4 times?
The other 4 times?
4 times out of 13, they're in total perfect agreement on a lie. If you do the math, 4 divided by 13, there is a massive 30.7% chance that their total, seemingly validating agreement is simply the mirror effect of witness A making an initial error.
Almost a third of the time, the corroboration is entirely fake. It's just an echo of a mistake.
It is a massive dependency trap.
Huh.
And Monteverdi highlights how courts routinely fail to recognize this dependency.
Because they just see 2 people agreeing.
Right. A judge or jury sees witness A testify confidently, and then witness B gets up and says the exact same thing. The court mistakenly assumes that this total convergence means absolute truth.
They treat witness B as an independent variable.
Exactly, failing to realize that B's testimony was completely contaminated by A's existence. The echo chamber creates this false sense of security. Psychologists call it the illusory truth effect, where repeated information is perceived as more truthful simply because it is repeated.
It's terrifying when you realize how often that probably happens. So we've looked at probabilities and combinatorics, but Monteverdi pulls out a completely different mathematical tool to dissect this problem from another angle, right?
He does. He applies risk analysis and the concept of the weighted average to clues. This is how he mathematically models contamination.
Contamination. So how does this reframe things?
This specific analysis really reframes the prosecution's strategy of, throwing everything at the wall to see what sticks.
The kitchen sink approach.
Right. In risk analysis, you aren't just looking at the isolated probability of a single event, you are calculating the expected value of the system as a whole.
Okay.
You are weighing the strong components against the weak components to find the true center of gravity of the case.
How does risk analysis apply to a courtroom setting? Give me an example.
Let's look at what Monteverdi calls the dishomogeneous scenario, or the 90-10 scenario.
The 90-10 scenario.
Imagine the prosecution presents 2 pieces of circumstantial evidence. Clue number 1 is phenomenal. It is highly reliable, let's say 90% accurate.
So something like a clear, undeniable fingerprint on the murder weapon, or a rock-solid alibi backed by GPS geolocation data?
Exactly. It's the kind of clue that almost wins the case on its own.
Okay, that's the 90.
But prosecutors often feel a psychological need to build a thicker file. They want to present this grand narrative of overwhelming guilt. So they add clue number 2.
And clue number 2 is the 10.
Yes. Clue number 2 is highly unreliable. Let's say it's 10% accurate. a blurry shadow on a grainy ATM camera a mile away from the scene.
Okay, so we have one 90% clue and one 10% clue. Intuitively, I feel like the 10% clue just sits there, mostly ignored by the jury, while the 90% clue does all the heavy lifting.
But when you evaluate the system mathematically, using a weighted average of their expected truth value, something fascinating happens. The system's overall reliability doesn't just dip slightly.
What happens?
It averages out to exactly 50%.
Wait, it drops all the way down to a coin toss.
Yes. In terms of risk analysis, this is a state of maximum entropy. It is an indeterminate balance.
See, because the terrible 10% clue completely neutralized the fantastic 90% clue.
The sheer weight of the bad evidence dragged the entire system down to the point of absolute uselessness.
But surely a human judge or a jury is smarter than a blind mathematical equation, right? I mean, if I am on a jury and the prosecutor shows me a crystal clear fingerprint and then a blurry shadow, I'm going to look at the 90% clue, give it all the weight it deserves, and just mentally ignore the 10% clue. I wouldn't let a grainy shadow cancel out a perfect fingerprint in my own mind.
That is what we love to tell ourselves. We believe we are rational actors capable of perfectly isolating variables. But Monteverdi warns of a massive cognitive distortion that occurs in this exact scenario.
Okay, what's the distortion?
It is a deeply ingrained psychological trap. Very often, the judicial system sees these two clues pointing at the same suspect. And because the first clue, the fingerprint, is 90% reliable, the human brain plays a trick.
What kind of trick?
It incorrectly assigns a high a posteriori reliability to the second, weaker clue, purely because it matches the outcome of the first one.
Oh, I see. The jury thinks, well, the fingerprint proves it's him, so that blurry shadow must definitely be him too. We can trust the shadow now.
Exactly. They assume the 10% clue is suddenly trustworthy. They create a halo effect around the bad evidence.
Wow.
They suffer from confirmation bias, using the strong evidence to artificially prop up the weak evidence. But this ignores a fundamental rule of logic and risk analysis.
Which is?
A source's reliability exists a priori.
A priori meaning beforehand.
Right. It exists before they even speak, before the evidence is even presented in court. A 10% reliable witness or a 10% reliable camera is still a 10% reliable source, even if they happen to accidentally align with the truth this one specific time.
Because their alignment is just a statistical accident, not a sign of hidden retroactive reliability.
Exactly.
It's like finding a broken clock that happens to be showing the right time. You wouldn't suddenly declare that the broken clock is a precision timepiece just because it matched the atomic clock for 1 second of the day. You'd recognize it as a broken clock that just got lucky.
That is a perfect translation of the a priori concept. But courts validate the broken clocks all the time. They allow the halo effect to convince them that a pile of broken clocks is somehow evidence of time passing accurately.
It's incredible how easily our brains get hijacked by that.
And to deliver the final mathematical blow, Monteverdi calculates what happens when you scale this pollution up. He calls this inquinamento indiziario, or evidentiary pollution.
Evidentiary pollution. That term perfectly describes the feeling of a case just drowning in useless information.
Let's do the math on the pollution. Let's combine one strong 90% clue with 5 weak 10% clues.
So one great piece of evidence and 5 terrible ones.
Right. The prosecutor thinks they are building an impenetrable fortress of 6 corroborating clues. They think they are burying the defense in evidence.
But the weighted average says otherwise.
When you run the weighted average, the overall reliability of the case plummets to 23.3%.
23.3. You started with a 90% solid case, and by trying to show off and corroborate it with junk, you mathematically destroyed it.
You mathematically drowned the strong evidence in background noise. It's like having a glass of pure spring water and deciding to add 5 spoonfuls of dirt to it just to have more volume in the glass.
You don't have more water, you just have mud.
Exactly. You just have mud. Trying to build a case by adding weak elements to a strong one doesn't reinforce the structure. It weakens the foundation until the whole thing collapses under its own contradictory weight.
This is such a crucial lesson for anyone trying to make a persuasive argument, whether it's in a courtroom, a boardroom, or an essay. If you have one great point, stop there. Don't add 5 mediocre points just to make your presentation longer or feel more comprehensive.
Because you are diluting your own 90% truth with a bunch of 10% noise.
Keep the signal clear. Avoid the noise. The math literally proves that brevity and quality are infinitely more powerful than volume and mediocrity.
It really does.
Okay, so we've spent a lot of time in the abstract world of pure math today, plotting curves, running combinatorics, calculating risk averages, but let's pull the conversation out of the spreadsheet and back into the human reality of a courtroom.
Which is where it really matters.
Because at the end of the day, a person's life or their liberty is on the line. We are talking about decades in prison. We are talking about families being torn apart, reputations completely destroyed, and the awesome, terrifying power of the state being brought down on a single individual.
This is where Monteverdi's work confronts the actual philosophical foundation of our justice system. We have to return to that Bayesian curve, the green line from our earlier graph.
The one representing strong clues.
Right. The line that arcs beautifully upward towards certainty.
But remember its defining mathematical characteristic.
Even if you have 10 or 50 or 100 strong, independent, highly reliable clues, the curve approaches 100% asymptotically.
It gets infinitesimally close. It might hit 99.999%.
But it never, ever touches 100%.
Mathematically, circumstantial evidence alone, no matter how vast or how compelling, can never generate absolute certainty. A shadow of a doubt is mathematically guaranteed to remain in the equation.
Which forces us to confront Article 533 of the Italian Code of Criminal Procedure and similar statutes worldwide.
The universal legal rule that states a conviction requires guilt beyond a reasonable doubt.
I want you to really think about this heavy question. If math proves that a shadow of a doubt always inherently remains in any circumstantial case, where is the line?
Yeah, at what percentage does a doubt transition from reasonable to unreasonable?
Can we as a society sleep at night knowing we are condemning someone to life in prison based on an 80% probability?
What about 90%? What if the math says there is a 99% probability of guilt? Is that 1% chance of innocence a reasonable doubt?
It is the most agonizing question in law, and it is where the math stops and the philosophy absolutely must take over.
Because math can't answer a moral question.
No, it can't. And Monteverdi is careful to temper his mathematical scalpel with deep legal context. He isn't suggesting that we replace human judges with calculators.
Right.
In fact, he extensively references the American legal scholar Lawrence Tribe, who famously warned against the tyranny of numbers.
The tyranny of numbers, what does that actually look like in a courtroom?
Tribe argued that a purely mathematical translation of a trial would be profoundly misleading and dangerous. If a jury is told by an expert that there is a 95% chance of guilt, the jury essentially stops listening to the human context.
They are paralyzed by the perceived authority of the number.
Exactly. Tribe argued that math cannot replace a judge's conscience. It cannot weigh the moral gravity of a decision, the contextual nuances of human behavior, or the societal cost of a wrongful conviction versus an acquittal.
Because you can't calculate the exact percentage of human intent or moral culpability. The metric of pure probability just doesn't fit the messy human reality of a crime.
Monteverdi also brings in the work of the eminent Italian jurist Michele Tarufo, who made a crucial distinction between what he called procedural truth and factual truth.
Procedural truth versus factual truth, how do those differ?
Factual truth is what actually happened in the real world. It is the objective, historical reality of the universe. Did suspect X pull the trigger at 9:00 p.m.? That is a factual truth. It either happened or it didn't.
Okay, so what is procedural truth?
Procedural truth, on the other hand, is simply the conclusion that the legal system arrives at based on its own artificial rules of evidence, its timelines, and its human actors.
So it's the court's best guess.
Exactly. Because circumstantial systems are intrinsically unable to express absolute logical mathematical certainty, there will always be an unbridgeable gap between the procedural truth declared by the judge and a factual truth of what actually happened.
The verdict is just our best legally constrained guess. It is a society agreeing to accept a specific narrative so we can move forward. It's not a magical revelation of the universe's objective secrets.
Ronald Allen, another prominent legal theorist, builds on this by pointing out that human trials require narrative structures, not just pure probabilistic models.
Humans need stories.
A jury needs a story that makes sense of human behavior, motives, and context. If you just hand a jury a Bayesian equation and ask for a verdict, you strip away the entire human element of justice. You lose the why of the crime, which is often just as important as the how.
So the complex math in this paper isn't meant to be used as some kind of justice vending machine where you insert the probabilities of the clues and a verdict just pops out.
Not at all. The math is a scalpel. It is a diagnostic tool meant to expose the severe cognitive distortions we suffer from when we evaluate clues.
It shows us our blind spots.
It is meant to prove that our intuition about accumulating evidence is deeply, dangerously flawed, and to force the justice system to be far more rigorous, skeptical, and critical when it relies on circumstantial cases. It's a warning system against our own psychological desire for easy answers.
Let's bring this all together. We have covered an immense amount of theoretical and practical ground today.
We really have.
For everyone listening, let's recap the main takeaways you need to remember from Giancarlo Monteverdi's analysis of evidence.
Okay, point number 1.
First, more clues do not mean a stronger case if those clues are individually weak. Adding bad evidence to bad evidence just mathematically accelerates you towards zero probability.
Right. Quantity does not equal quality.
Second, the concordance paradox. A room full of weak witnesses who all agree with each other might mathematically just be a room full of people sharing the exact same lie. Agreement does not equal truth.
Never forget that one. It's the biggest trap.
And third, the contamination principle. A brilliant, rock-solid piece of evidence can be entirely drowned out and neutralized by a prosecutor trying to show off with weak, noisy, corroborating facts.
It completely upends how we think about building a persuasive argument. It is a masterclass in the dangers of trusting our unverified human intuition.
Before we sign off, I want to leave you, the listener, with a final lingering thought to mull over. Something that builds on this incredible math, but takes it into the very near future.
Oh, this is a fascinating thought experiment.
We've spent this time seeing just how terrible human intuition is at processing probability. We fall for the echo chamber, we create halo effects around bad evidence, and we get totally dazzled by false concordance.
Right, our brains are just wired poorly for this.
And we know that judges and juries are flawed, biased humans. But as artificial intelligence advances at lightning speed, we will soon have algorithms capable of doing this exact Bayesian math, this combinatorics, and this risk analysis on evidence in real time during a trial.
A literal, unfeeling mathematical scalpel running live in the courtroom.
Imagine this scenario. The trial concludes, and before the jury goes back to deliberate, an AI flashes on the courtroom screen that the maximum mathematical probability of guilt based purely on the combinatorics of the clues presented is exactly 87.4%.
Just a cold, hard number on a screen.
What happens then? Will any human judge or jury ever dare to convict again, knowing mathematically that there is a 12.6% chance they are ruining an innocent life?
It's paralyzing.
Or will the raw, cold, unyielding truth of mathematics paralyze our justice system entirely, making it impossible for human beings to ever cross the threshold of reasonable doubt?
It is a profound question about what we value more as a society. The pristine certainty of numbers, or the messy, necessary finality of human judgment.
Thank you so much for joining us on this deep dive. I hope this conversation has given you a new lens through which to view the world, and I encourage you to start questioning the obvious facts and the webs of tiny clues in your own life. Remember, just because someone points at a lot of smoke doesn't mean they found the fire. Sometimes it's just a fog of bad math. Until next time.